Welcome back to part 2 of the 350 Pontiac rebuild. Alright, so we've got a lot of parts here. What I want to do is I want to walk you through some of the parts that we came up with on this, and then we'll get into the actual rebuild. We did get the block machining done, with the exception of a few more things we have to do to it, and I'll get into that later. So first of all, we decided to go with an Eagle crankshaft, and this is a 4340 forged unit. And we also went with Eagle 6-inch 800 thousandths long rods. It is an H-beam rod with a full floating piston pin setup and a set of forged Ross flat top pistons with 2 valve reliefs. Now, all of this rotating assembly has already been balanced. You can see some of the metal removal and so forth that they did here, and then on the connecting rods you can see that some of the rods have been trimmed on top for balancing. These are usually pretty close. They actually did a little bit of metal removal on this side as well. So, and one nice thing is some of this stuff, in fact, the rotating assembly came from a place called Butler Performance. I've used Butler a few times for when it comes to Pontiac stuff, guys. I would recommend Butler Performance. They do a great job. I've never really had any problems with their components. They will sell you a balanced rotating assembly. They do the balancing themselves. They have an in-house machine shop, so they do a lot of this stuff, and they specialize in Pontiacs. And the nice thing is they give you a really nice balance sheet when you're done, so you have all of your weights and sizes and so forth. And then of course the Ross racing piston data. All this stuff is really critical. When you do a build like this, you need to make sure that you really are carefully read their instructions from the manufacturers, because there's a lot of things that you got to pay attention to when you put one of these together if you're going to do it right. So rods, pistons, and also we went with total seal rings. And we got the Performance Speed Pro bearings, rods and mains, and that's basically the lower end. We did go with a Howard's Big Daddy Rattler cam. It's one of the Rattler series cams. I've had really good luck with these. I actually have one of these in my 427 Chevy. And so the roller cams, and I don't know if I realize there's the flat tappet situation, but I'm going to be honest with you guys. You know, the luck that I've had and the failures that we've had with flat tappet camshafts and the high zinc oil and issue like that, I'll be honest, I'm pretty much done at this point in my life with flat tappet cams. I'm just gonna go roller on everything, and if somebody wants to do a flat tappet, they can just go somewhere else, because I'm just not gonna deal with those anymore. So that's our rotating assembly, and we'll get into all the intricacies and the measurements here, but I just kind of want to kind of give you a once over of the parts that we have. And of course, we've got a new oil pan back there, a windage tray. We have Harlan Sharp roller rockers, ARP main studs, ARP head studs. And a lot of people bag on the 350 Pontiac, but if you get good components in it, it's actually a good engine. The 350 Pontiac has almost the exact same bore and stroke combination of an LS1. So, you know, and those motors are no slouch. You understand that. So. We also are going to go with an Edelbrock intake manifold, Edelbrock carburetor, MSD distributor, and just, you know, pretty much the best of the best with all the internals. So, all right, so now what we want to do is we want to take a look at this block, because we are using the factory 350 Pontiac block. Okay, so now we got to take a look at the engine block. One of the things that I would recommend highly here is take a thread chaser, and I've already chased all the threads on this block. I spent quite a bit of time off camera, and I went through and I chased every single thread hole on the heads, on the sides of the blocks, on the bell housing area, and the mains, of course, the main cap bolt holes, and I went ahead and put the studs in. This block has been prepped. We cleaned it, Magnafluxed. I bored the cylinders, bored and honed them to size. So the bore size here that we went to is 3.905. The standard size is 3.875, and we went 30 over, so that makes it 3.905, which is very similar to an LS1, by the way. Now, according to Ross pistons, the manufacturer, this forged piston, they want to see about 4 thousandths clearance. Now we need to calculate the clearance here. So we need to measure our bore size and verify that it's 3905, which I've already done. And then we need to measure our piston skirt here. So it's always a good idea to verify what the machine shop has done. In this case, I'm the machine shop, but we're going to take our micrometer and we're going to set it for our bore size, which is 3.905. I've already got this mic set for 3.905 and I've locked it in place. You can use T gauges, which I don't really like, or you can use a bore gauge. I like to use a bore gauge. So I'm just going to put the bore gauge right in between the fingers here. Okay, so if you can see this, I'm right on 0. When I put these between the fingers here, that I have duplicated my bore size here on my dial bore gauge, and then I just simply take my dial bore gauge and I put it in here to verify my reading. I'm right on 0. So my bore size is right at 3.905. It's the same all the way up and down. It's the same no matter which direction I go here. And I've already actually pre-verified that beforehand. I knew that was the size. So that's how you do it. You just calibrate your dial bore gauge. If you want, you can have the machine shop do it. Now we need to make sure that our clearance is correct on our piston. So like I said earlier, Ross wants to see about 4 thousandths clearance. Now where you measure this piston skirt is important. They tell you how far down from the top to measure. In the case of these Ross pistons, I took the measurement from the top, and they actually want you to measure it really close to about where the center of that pin bore is. So we're just going to take our micrometer and we're going to measure that piston. Now we've got this set for the bore size, so this should go over real nice. See, it goes over. So what we're going to do is we're going to unlock it, and we're just going to measure that piston perpendicular to the wrist pin, right there about the center of that pin bore. My piston's measuring 3.901. The bore is 3.905. That's 4 thousandths. That is exactly what Ross says they want this clearance to be. Now, it's actually pretty simple to do that, because when we machine the block, we bore it to exactly 30 thousandths over. And what they do when they manufacture the pistons, you guys, is they manufacture this piston so that it is actually 4 thousandths smaller than the bore size. So we bore the block right on 30 over, and the clearance is manufactured into the size of the piston. So as long as I'm 3.905 and as long as the pistons are the size they say they are, you're going to have 4 thousandths clearance, and we do. So our piston to cylinder wall clearance is right on the money, right where it needs to be for this engine, which is good. So that's a good start. Okay, so for this next step, you want to take your bearing. We've got our main bearing, and we've got the bearing for the block installed in the block. And remember, the bearing that has the groove or the hole in it goes into the block. And then you want to put your other bearing into your cap. This one doesn't have, it does have an oil slot, but it doesn't have a hole in it. One of the nice things about the Pontiac caps is most of the time they're marked. They have the marks cast into them, so make sure you get the right cap. This is our #1 cap here. And also you want to make sure that these go on the right way. The locating notch that is machined into the cap, and there's also a locating notch machined into the block for that locating tang. Those both go to the same side of the cap here, right? And there's usually an arrow on the cap too. So there's an arrow on this pointing this way, denoting the front. So that's the front of our cap right there. So what we want to do is we just want to take and we want to put our cap on. Now a lot of blocks have a machined area here that the cap fits into. On the Pontiac, they use locating dowels, but even so, just kind of take a soft hammer and just make sure that that's seated all the way down. Now, really critical here when we use ARP studs, you have to make sure to get the right torque that you use the ARP lube on here. Getting the correct torque on these caps with ARP studs, it's absolutely critical that you use this lubricant. They actually have a pretty good video on YouTube, if you want to take the time to watch it, that walks through the process of torquing the ARP studs without this and with it, and they show you the difference. And it's compelling. Suffice it to say, putting this lube on the threads, and you also want to go ahead and get some on the washers there. They give you way more than you need for these studs, so be generous with it. Get some on the washer so you get lube on the threads, and you have lube in between the washer and the cap, and in between the fastening nut and the washer. So just goop that all over there. And it really does make a difference when you're torquing these as far as getting the right torque value. So make sure you got a good amount of that on there. Run the nuts down, and then we're gonna want to torque that to specifications. We don't have to go to full torque on these to check clearances. In fact, most bearing manufacturers recommend going to half torque. So we're just going to go to 60 pounds here to get our crush, even though the full torque is actually more than that. Always take the tension off your torque wrench. Now that you've got that torqued on, the next thing we need to do is we need to mic our crankshaft journal, and you want to mic the journal that actually goes into that bore. So we're going to see what this measures. Now you can use a 3 to 4 mic or a 2 to 3. You'll get it with either one. This is a 2 to 3. So I'm measuring just a hair under 3 inches. It's actually 2.9995. It's not unusual to see that on an aftermarket crank or even a factory crank. It's just a hair under the 3-inch mark, which is pretty good. So now that I have mic'd that, I'm going to do something similar I did with the cylinder. I'm going to lock my mic right there, and I'm going to calibrate my bore gauge. Now I've changed the mandrel here and set this up so it matches the size of our crankshaft here. So we're going to do the same thing we did on the bore. We're just going to get our bore gauge between the fingers of the mic here, and then we're going to zero out our indicator. Okay, so we've zeroed out our indicator based on our crankshaft size. And now we're just going to gently go into that bore, and we want to see the difference here. Three thousandths clearance, which is perfect for a main on that. For every inch of journal diameter, you want about 1/1000ths clearance. We got a 3-inch diameter journal, and we got 3/1000ths clearance. So we're really good. Now I'm going to go through off camera right on 3/1000ths, and I'm going to check every one of them. It's important that you check every one. So for example, I'm going to put the bearings in the number 2 cap, and for that I'm going to measure the number 2 journal and make sure that those two are compatible with each other. You can't really skip any of this. For the sake of not being redundant, I won't do that on camera, so you kind of got the idea of what we're doing here. So I'll get that done, and then we'll come back and move on to something else.